Today, we're going to be learning how to do what's known as a flame test lab. Alright, I'm going to go ahead and get one thing out of my drawer. This is what's called a 12-well spot plate. So I'm going to go ahead and get this out of my drawer. Alright, so what is the purpose of this lab, a flame test lab? Every chemical gives off a certain unique color flame. And so what I've got, and I want you to look at what I've got laid out up here in front of you. I've got seven different containers of chemicals laid out here. Every one of these chemicals will burn and give off its own distinct color. So what I want you to do tomorrow in lab is basically what? Burn each one of these chemicals, write down what color it gives off, and then what I want you to do is this. I want you to grab one of these vials. And in this vial is an unknown chemical. So, guess what you're supposed to do tomorrow? You're going to burn these 7. Then after you've burned them and recorded the color that they give off, what are you going to do?
Burn that.
Burn this unknown. And what should you be able to do?
Identify it based on the color.
Based on the color. So this one should match one of these other 7 over here. So you should be able to identify it. Kind of easy in terms of making sense, ain't it? That's the whole idea of this flame test lab though. So the first thing I need you to do tomorrow, you're going to get one of these 12-well spot plates, and what I'm going to do is come over here. And I guess you could say the first thing I'm going to do is I'm going to get a little bit of all 7 of these. So I'm going to go through and get a little bit of all 7 of these chemicals. You notice how I'm talking slow is to imply that you might write something down at this point. So number 1, get a little bit of each one of these. And by the way, if you want to say salts, that might sound a little sexier and sciencey to say. Obtain one of each sample of salt. Alright, so get one of everything. Now again, my procedures are going to be kind of crappy, so you're going to have to write some better ones. Now, do you notice something about how I've got these jars laid out? Each one has got its own, by the way, we call these scupulas. I know it's not a very manly name, but it's a scupula. Each one has got its own scupula, which means through the duration of the lab, that scupula needs to be what? With that bottle. In other words, do we mix them? No, I will be quite vexed with you if we do such things. So here's what we're going to do. I've got this. It should be clean and dry before we start. I'm going to take the lid off. And then I'm going to come over and I'm going to get just a little bit. So you're going, Mr. Scully, how much is a little bit? I'm saying that's a little bit. So I'm going to walk around. This might even be too much. Hey, if you do the lab and you find out you didn't get enough, guess what you can always do? Come back and get some more. I'm trying to keep you from walking in and taking like some gigantic scoop of something and then us throwing most of it away because this stuff costs money. So I'm going to come over. And what I would do is, and this is where some of you will goof up. Some of you will go through here, get one of everything, and then you'll sit back down and go, I don't know which one's which anymore. Which means it might be a good idea there's numbers on here. If me and Logan are in a lab group together, I might go, Logan, number 1 is barium nitrate. And Logan can write that down for me, and when we go sit down, we'll know what everything is, right? Matter of fact, in your procedures, if you drew a little picture of a spot plate and just wrote out what you put in each little one, that would actually work great in procedures. Do some of that. Now, one of you will do this, at which point you're going to lose a letter grade tomorrow because you're going to go over here and you're going to get something and you're going to walk away. Well, I'm going to be watching you walk away and leave that. And what I'm going to do is come back behind you, give you a dirty look, close, put the lid on good, and put it back the way it is. And I'm going over and I'm deducting 10 points from your grade at that point for having to clean up behind you. I just hope you don't go down the entire run because that would be 7 containers at 10 points each. So in other words, every time you get something, what you need to make sure to do, put the lid back on, put the scoop back with it. Don't scoop. I don't want it laying down here, blah, blah. I want it set just like it was when you got in here. Now, this will be a good question. What happens if somebody comes over here, by the way, I'm about to touch my eyeball, and that's something you should never do in the lab. Where's my safety goggles? Don't judge me, world. All right. But anyway, get these. What should you do though if you get too much? Inevitably, one of you is going to take a scoop and go whop, and you're going to get way too much of something than you ever needed. In other words, you do a lab that says get 2 grams of NaCl, and you grab 5 grams. What do you do with the extra 3 grams? Oh, Mr. Cole's going to be mad. Start putting it back in there? No. Do not ever take something from what you've got out and put back into the container again. Why? As soon as it leaves the container, guess what we consider has happened? It's contaminated. We do not take that because you dump it in this plate, and guess what? You get ready to put it back and you're like, I can't remember if that was the potassium or strontium. I'll just put it back in the strontium. And it turns out you had potassium the whole time. I've actually had somebody do this before. We've done lab work with sugar and salt. Sugar doesn't conduct electricity. Everybody in the lab's going, Mr. Cole, our sugar's conducting electricity now. And I'm like, sugar doesn't conduct electricity. This is strange. And then finally somebody raises their hand and goes, I got too much salt out and I think I put it by accident back in the sugar container. Do not ever put something back. We throw it away, we dispose of it. It's gone. So, number 1 tomorrow is you need to come through and do what? Get one of every one of these. Make sure you know where it goes. And grab one of the unknowns. So I'll come back over to my table. Get ready to do my lab. Alright, I got that. Now, what else do I need? I need my test tube rack. I also need my test tube tongs. Hannah, can you grab me some test tube tongs? Test tube tongs. Test tube, can anybody help me with test tube tongs? Ah! It's a hard knock life for me. It's a hard knock. Those are bigger tongs. Test tube tongs. Test tube tongs. Bam, I got my test tube tongs. I'm ready. So, test tube tongs, I'm ready. I'm going to go over here to the hood. So, step number 1, get a little bit of every one of those samples of salt. Step number 2, I'm going to get some hydrochloric acid. Hood's getting turned on. I'm going to raise, theoretically, the sash ain't actually supposed to be over this tall, but for the sake of the video, we'll go ahead and raise it up. So, what I'm going to do is, here it is. It says 6 molar HCl. I'm going to turn off the thing so you can hear right now. You need to take the top off the HCl, and there's a pipette on the side of it. And what you can do is use the pipette to reach inside, and you're going to be like, how much HCl do we get? I'm about to blow your mind. About this much. About that much. In other words, I'm not telling you an exact amount. All we're going to use this for is cleaning. So I'm going to get about that much in there. Now, for the sake of this lab, I'm not going to get the actual HCl out because I don't want to have to dispose of it. But make sure that when you are done, what happens if you got too much HCl in here? Should you suck it back out and put it back? No. Nope. There'll be a waste container back here. You dispose of it in the waste. When you're done, put the pipette back in this little thing. Make sure you put the lid back in it. If you do not do these steps, guess what?
10 points.
10 points. I will be happy to do it for you. Should the lab be over and I just find this undone, everybody loses 10 points. Which means if you see Logan do it, Sam probably should come behind Logan, yell at Logan, then put the thing back in for him and take care of it. Make sense? Because I'm going to charge a hefty price if I have to. So we're going to pretend I'm getting some HCl. Squirt, squirt. Notice my head's not under the hood. Bam. Video editing. Bam. And I've got my HCl. So do you see roughly how much I've got? About what, an inch worth in the bottom? It don't have to be a whole lot. But I'm going to get my HCl. Alright, come back over. Oh, I'm doing great. So I've got my hydrochloric acid. I need to get a burner. Somebody locked every cable I got.
Where's the key at?
I got a key right here.
Thank you. I'll tell you what, y'all get paranoid on this locking the drawers thing. Alright, so I'm going to get me a burner out. I'm going to get a striker out. Oh, well, this is like a brand new burner. So let's get us a burner. We've already went over how to light burners. So I'm going to get my burner over here. Gas on, air off. There we go. Burner's ready to go. So I got my burner. Now I'm gonna come over. This is what we call a loop. Man, that one's disgusting. I'm trying to find the least nasty one in here. So this is a loop. You can see why you call it a loop. There's a little loop on the very end of it. So step number 1, do what? Get one of each of all those, right? Step number 2, get
HCl.
about that much 6 molar HCl, right? Step number 3, clean. Now you're going to have to make sure and tell someone how to clean. I'm just going to say clean the loop for my step 3. You need to have more words in yours than that. But step 3, clean the loop. So how do we clean the loop? We clean the loop by dipping it in the HCl. So notice this. This is how you clean the loop. You dip it in the acid and then take a while. Guess what I'm about to do? I'm going to burn it. Cook, 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 cook. Look what happens to that loop. I got it red hot at this point. And somebody usually is like, how do we know if it's clean? And I was like, well, it's red hot. Well, it's giving off the color red. That's because it's red hot. It doesn't necessarily mean that there's a chemical on it. It just means it's really hot. If you're in doubt, cool it off a little and stick it in. You can do it again. Rinse and repeat. But this is how you clean the loop. You dip it in the acid. You notice which part of the flame I'm putting it in?
The blue.
I'm putting it in that blue tip down in here. Now I've got this loop clean as all get out, or at least as clean as I'm going to get it. Lauren.
So how many times do you have to do it? Like once? Or
Hopefully just once. If you have to do it twice, you can do it twice. In reality, once should do it. Now, here's what I'm going to do. Remember what the purpose of the lab is. You are going to burn each of these chemicals and see what color they are. But what will happen is this. I'm going to go dip it in that first chemical, and I cannot get it to stick to the loop. Aha! Distilled water. So what I'm going to do is this. The distilled water shouldn't have anything in it. So I'm going to wet my loop with a little distilled water, and now I can stick it in here, and lo and behold, notice what happens. Can you see it on the camera? It sticks. Now this is where I'm going to ask Amberly to turn the light off for us. By the way, the lab tomorrow we'll have the lights off for the whole lab so you can see. Because y'all got to see the colors of these burns. I do not want to stick it dead center. All I want to do is like get it on the edge so if it drips, it don't drip right down the center of the burner. So I'm going to get right on the edge. And you can start seeing that color that it gives off. And then all I'm going to do is go to my data table and I'm going to write down what color. Do it again, do it again. Fine.
Yes.
If you want to repeat, moisten it one more time. Moisten it. It's an odd word. Moisten it, stick it back in, and you can, as long as I'm doing the same chemical, I ain't got to clean it. Alright, but take a wild guess. When I'm done with that one, before I move to the next chemical, guess what I need to do again? So I don't know where we're at on steps. Step number 1, get that. Step number 2, get acid. Step number 3, clean loop. Step number 4, burn chemical. Step number 5, clean and repeat for the rest of the lab. So what you need to do next, after you've burned this one chemical, what am I going to do again to clean
Clean
it?
the loop.
How you clean the loop?
You wet it and then put water in it.
Stick it in
Wet it.
hydrochloric acid.
Stick it in hydrochloric acid.
Stick it in the hydrochloric acid,
And then you burn it.
and then we try and burn it off.
On the blue.
And we're going to get it good and hot down in there. By the way, if you're wondering why it's giving off some of these colors right now, it's because it's not a clean loop, really. But anyway, we're going to stick it in there, but that's because I'm not actually using acid right now, which would help in my cleaning. Now, through the course of your lab, you might notice your acid turns like no telling what color. Feel free, if you desire, if you want to get fresh acid and start over, go back to the hood. There will be a place to dump the acid. Dump your waste acid out and get some fresh acid in there. Alright, so I'm going to sit here. It's clean, and then what would I do after I've cleaned it?
Get the next.
Move on to the next one, and just repeat and repeat and repeat. What should be pretty much the last thing you do?
Unknown.
This unknown, Amberly, if you can relight us back up. I'm going to turn off my fire. What should be the last thing? The unknown. Now, I'm going to give you a hint. The unknown should be your last, but I'm going to give you a little hint about something. Cupric nitrate is the pain in the rear end to clean off your loop. So I'm going to go ahead and do something. I would wait till dead last to do cupric nitrate because it's so hard to clean. I'm going to go ahead and show you something. By the way, if you have a hard time getting something out, just get up in there and you'll get something out. Look at the cupric nitrate. Yeah, it's kind of blue. I'll give you a hint. Look at the unknown. It ain't this. Which means you can rule out cupric nitrate as the unknown. Which is why I would do the unknown before I did. It's not, because I never poured this out. I'm going to assume the scoop is hopefully clean. Look at Sam over here telling me why I can get out of my video. Tell you what, this is my house and you won't in here. By the way, please make sure you put the lids on tight. Some of this stuff will literally, calcium nitrate will literally turn to liquid. It'll suck moisture out of the air. One of you will come over here and be like, Mr. Cole, it's water. No, it's a calcium nitrate. It's dissolved from moisture in the air, which is why you need to put the lids back on, store those with them. Now, I do have a couple of little exceptions. You got the general idea of what you're doing tomorrow, right? You're burning the chemicals, writing down what the colors are, make sure you clean your loop, that kind of stuff. A lot of people say that sodium and potassium burn the same color. So if you notice on the data table, you're supposed to do sodium twice and potassium twice. Did you see that when you were writing it down? Yeah, you're supposed to do sodium once with your bare eye. Then you're supposed to do sodium a second time with a piece of this cobalt blue glass. So in other words, you watch it burn through the glass. Now, in my personal opinion, pretty much everything looks blue through the glass. But anyway, you're supposed to look through, and sodium and potassium will be distinct when you look through the glass. I'll be honest, one of them looks pinker than the other when you look through the glass at it. So it's a very easy way of telling sodium and potassium apart. And there's the pieces of glass laying over here. Okay, so we're done with the lab. I know what my unknown is. I've done all this. By the way, if you're wondering how fireworks get their colors, all fireworks have the same powder, and then what you do is you mix a different chemical in with it. You mix a different salt. If you want it, for example, I ain't going to give away what they burn, but like some of them burn different colors, reds and greens. You dump in that salt with it, and when the fireworks go off, that's where you get your colors from in the fireworks, is the powder burns. So, anyway, you got this. So we're done with the lab. We need to clean up. Burner, it's cooled off. Needs to go back to the drawer. Put up our burner. Loop, hopefully you've cleaned it. Loop goes back to here. What about all these waste salts that I've got left over? I'm not going to throw them in the trash can. I'm not going to go in the sink. I'm going to go back to the hood. And I'm going to clean them all out in this big, skanky looking jar over here. And I'm going to take my distilled water. I'm going to rinse it out good. After I've done that, I'll go back to a sink and I'll wash it out good after that. By the way, if you ever need to use soap, we use Alkanox brand soap. The most trusted soap by chemists everywhere. Little plug commercial. Alkanox does not mean it's made of alcohol. It's a brand name of soap. So anyway, so that's the soap we'll be using. You can soap it and wash it out. So there's that. Got him clean. Now, what about this big guy? 6 molar hydrochloric. I'll just walk over and toss it in the sink. No. Go back over. I'll have a place in the hood for the waste acid. How will we know? It will say waste acid on there. Pour it out there. So what do I do with it now? Because guess what's still in there? Acid. Here's how I would go about taking care of this. I would spray this thing. I'd spritz it up more with water. And I would sit here and spritz it up with water. I would spritz. You get the idea? I would rinse it out a whole crap load of times. And then I would carefully, matter of fact, I'll be honest, what I would probably do, sure as the world, one of y'all will try and stick this under a sink, and guess what you'll do?
Splash acid on you.
You'll splash acid back up on yourself. Now, hopefully you could actually perform this without doing it. But if you're in doubt, just take a beaker and rinse this thing out about 400 times. In other words, you just keep rinsing it out and rinsing it out till you got the acid out. If you finally, the soap will be a little basic. Spray some soap in there. You can rinse it out. You can rinse it out. You get the idea? Rinse it out, rinse it out. And if there's any doubt, I'll give you a little bit of baking soda. You can throw some baking soda in there and neutralize the daylights out of it, all right? And that'll be the end of it. I just had water, so mine's good. I can clean it up, put it back up. Those can go back. Striker needs to go where? In the drawer over here. What did I just do to lose 5 points?
Put it back.
Put my water bottle back up. I've got my table clean. Everything's got its lid on. Good. Acid's got its lid on. Everything's in its place. All right. Y'all good?
Good.